Right, so we've gone through the introduction. Now it's time to take a look at how these questions are structured. So the first question, diagram shows a sketch of y equals fx. So we don't need to know the actual algebra that produces that curve, because all we're going to be doing is moving it using the rules that we've noticed. So on the same diagram, sketch the graph of y equals fx plus 3. So long as you've gone through my introduction, you know that fx is the output, and this means that we're adding 3 units to the output, which means we're going to be adding 3 to any y coordinate. So that minus 2 is going to be added 3 to, which would take it to plus 1. Okay, and mark clearly the coordinates and the point where the curve crosses the y-axis. So it's going to look the same as that, but it's going to cross at plus 1. Diagram shows the sketch of y equals gx. On the same diagram, sketch the curve of x minus 3. So this is going to move it 3 units in the positive x direction. So it's going to take the x coordinates and it's going to move that 3, so it's going to take it to 5. Mark clearly the coordinates of the point where the curve crosses the x-axis. So it's going to look exactly the same. But cross at plus 5. Diagram shows the sketch of y equals x squared. Well, that's what we were practicing with. On the same diagram, sketch the curves. So 4x squared is going to make it much steeper. It's going to take each output, each y coordinate, and multiply it by 4. So you just want to show that you get a much steeper graph that is still symmetrical. So that would be y equals 4x squared. And negative x squared is a reflection of the original curve. So what you want to do, I usually find it easier to do reflections when the mirror line runs along my line of sight. So that, it doesn't have to be perfect. You just want to show the examiner you understand that it's a reflection. So that's question 1. Question 2, y equals fx, x plus 6, so that's going to move it 6 units in the negative direction. So the point 0 is going to end up over here at the point negative 6, but apart from that it's going to look exactly the same. Plus 6 to the output is going to move that 6 units up, which means it's going to end up at 4. So that shows what you want there. This one, y equals x squared. 2x squared is going to make it steeper. Negative 2x squared is going to make it steeper and reflected. So you want to show that you've got a steeper gradient and it's reflected. So that would be y equals minus 2x squared. And then this is going to basically add 3 units to that. So it's going to move it up 3 units. So you want to show that you've got that same steeper gradient, but you're adding 3 to take it up there. 3 units up your y-axis. So hopefully I'm not going too fast. If you watched the introduction video, then I'm sure these are quite straightforward now. So we're adding 3 to the input, which moves it 3 in the negative direction. So 1, we're going to move 3 this way, we'll end up at -2, and then the graph looks the same. G of x cuts at -3. We're adding 2 to the output, which means it's going to end up cutting at -1. And you need to show the point where it crosses the y-axis, which is what we've done there. This is the graph of y equals x cubed. On the same diagram, sketch the curve of minus x cubed. So this is going to be a reflection. So it's going to reflect in the y-axis. So this part is going to go like that, and this part is going to go like that. So that's minus x cubed. Minus x cubed plus 4 is going to take that red curve and march it up the y-axis 4 units. So that would be y equals minus x cubed plus 4. Diagram shows the sketch of y equals fx. On the same diagram, sketch the curve of fx minus 2. Output is having 2 units subtracted from it, so it's going to move all the y coordinates down 2, which means that 3 will become 1. Then the graph does the same. It's only interested on the point where the curve crosses the y-axis, which we've marked as 1. Diagram shows the sketch of y equals g of x. On the same diagram, sketch the curve of y equals minus gx. So that's the reflection. The output, the coordinates of the output become negative. So we want to make sure that we have this reflection. It's quite a tricky one to draw this. So from there it's going to go out and back in again, and here it's going to go in and out. So again, not the most artistic of drawings, but you can see that I'm clearly trying to show there that we've got that reflection. And that's -5. And the final question, diagram shows the sketch of y equals hx. On the same diagram, sketch the curve of hx minus 3. So it's having 3 taken off its input, and the effect of that is moving it this way 3. So you'd end up with that moving to 7. So those are transformations of graphs. Hopefully if you watched the introduction video, those were quite straightforward.